camera.
Sierra, we
All right.
got a picture of Eric to show you when you get back.
So funny. Okay, anyway.
All right, we are going to go over the Chapter 6 review packet, just a couple questions. And actually, I'm missing a couple of them on my slides, so I'll have to handwrite them on here. But the quiz tomorrow looks exactly like this review with different numbers. I'll be brutally honest, okay? It is this long. So if you know the definitions, it goes very quickly. But if you have to look up what sign means before you do every single problem, you're gonna have trouble finishing, okay? For example, just this first problem, cosine of B, you should know right away that's adjacent over hypotenuse. You write it down and you move on. Cotangent, well, that's the flip of tangent. Tangent is opposite over adjacent, so this one would be A over B, and you're done. Okay, do you get what I'm saying? That if you don't know those definitions, it's gonna take a lot longer. Okay. Did anybody do this and have a question on anything on the first page? I might suggest we should talk about this one right here. Do you know how to type in the cosecant of 46 on your calculator?
1 over cosine of 46.
1 divided by sine of 46, yes.
Oh, shoot, my bad.
Yes, you need to be in degree mode.
Wait, Mrs.
Yes?
For a test like this, are we going to have our calculator on it the whole time?
Yes, absolutely. Yep, you will have your calculator. You will also have worksheet 11B, or at least you will have a copy of that, the reference sheet with the unit circle on it and whatever, okay? The formulas for angular linear velocity, all that stuff will be on there. All right, I'm going to skip, unless someone has a specific question, all the way to number 15. 15's not hard, but I always have some students who just kind of draw a blank. Four fifteenths of means times a circle. Well, what are the degrees in a circle? So this is just 4/15 of 360 degrees. Okay? Just make sure that one doesn't floor anybody. Number 17 can be a little bit tricky. What Greek letter have we been using for a central angle? Just theta, yep. Okay. And the radius is 53 feet. And we want to know the distance around that you've traveled. What is that called? Yes, or if it's a piece of the circumference, it's called an arc length, which is S. Yep, just like you said. So what's the formula between those things? Okay, so all you're doing this question is taking 67 times pi divided by 4 times 53, and you'll get the answer. I don't know which one it is, so I can give you a minute to type it in, but do you need one?
No, I'm just being really lazy. Not
Oh. That wasn't too strenuous, was it?
No.
All right. Number 19 has several complicating issues. The first is that the answer on the back is wrong. The second is that on the test, I put down 2 answer blanks because it says part A and part B. But it's one of those really stupid questions where the book actually has 2 questions in one. Do you see what part B has 2 question marks? So you just need to be really careful on the actual quiz tomorrow that you remember it's actually asking for 3 things, okay? That you read the question carefully, because I only have 2 blanks down like an idiot. Okay. The thing the book did wrong, or the computer, whatever, generated the answer key to this. It is computer generated answer key. It says 2.4 feet in diameter, and they use that number as the radius. Okay. The radius should be what, guys?
1.2 feet.
All right. Part A says, what is the angular speed? Angular speed is always measured in what per what?
Radians per minute.
Revolution.
Radians per some kind of time. Okay? We need radians per time. So they gave us something close. What did they give us?
Revolutions per minute.
1,100 revolutions per minute. If that was in radians, we'd be good to go, because I don't care what kind of label it has, as long as it's radians per time. So 1 revolution is 2 pi radians, so we have 2,200 pi radians per minute. And you can multiply that out if you want, but otherwise that's the answer to part A.
Well, we get marked off if we don't count when we get that, so they.
Say that again?
Do you want us to write it all out, or do you want like an exact answer like that?
I don't care. Either one is fine. Yes. Good question. Either one is fine. I will take either one. All right. Part B says, how fast is a point on the circumference of the wheel traveling in feet per minute? To change 2,200 pi radians per minute to feet per minute, we need to go from an angular to a linear velocity. So the rule or the formula on worksheet 11B says you multiply by the radius. So what is the radius?
Radius is 1.2 feet.
So if we multiply that, 2,200 times 1.2 is 2640. Don't lose pi, or go ahead and type it in your calculator, either way. But that is feet per minute, which is the answer to part B, but not the whole answer, right? Because for some odd reason they said also in miles per hour, just to make this more difficult. 2640 pi feet per minute. We're 60, what are we doing? Miles per hour, right? So 60 miles. Can you see that green on there or not? 60 minutes per hour. Did I just say miles? I don't know. Minutes per hour. And then what are we supposed to do? Miles. So we need 5280 down here.
You need to remember that.
Yeah.
Yes. It's not on the final. It is on tomorrow's quiz. If you can't remember, just ask me. I'll tell you. It's 5280 feet in a mile. Okay, so if we do 2640 times pi times 60 divided by 5280, and I put the pi in this time. Yikes, what did I do wrong? Oh, I forgot the 5 and 5,280. That could be a problem. Like, I don't think it's going to 1,700. Okay. 94 miles per hour, roughly.
I got that. 94.247.
Yep, yep.
Or we do 30 pi. 35
You can
more.
leave it in terms of pi. I don't care, but
Better. 94.2%.
I just went ahead and changed it to a decimal for that one. All right. Felt like oh, I know what I was going to say about this question. There is a question on the final, okay, that asks you this information. It gives you the radius, doesn't give you the diameter, gives you the radius and the RPMs, and it wants the linear velocity, okay? It does not ask you to do a bunch of converting like miles per hour to feet per second to whatever. It says whatever labels there are in the question are fine. But you do have to know how to do that, okay? You just multiply by 2 pi and then by the radius, but, all right. Number 23 was crossed off, right? Everybody
Yeah.
remember
Yeah.
to do that? And that's all I have, but I wanted to talk about 26. I don't have a slide on it. Okay, back up. Where's my little, okay, I gotta move this out of the way.
Do not use, oh, dang it, we can't use
I think it's 26. Does it say like sine pi over
Pi
4?
4 minus cosine pi over 4.
Okay, you get to use a unit circle. It's on 11B. So honestly, do you remember how to use the unit circle? Oh, that's a circle. Oh, that's even, yeah, that's horrible. Do you remember the first number in every ordered pair is just the cosine? And the second number in every ordered pair is just the sine. So if you went around to pi over 4 and you found this, you'd have both the cosine and the sine, which is square root of 2 over 2 and square root of 2 over 2. But for a minute, I'm going to pretend you don't have that. And the way I really wanted you to be practicing was to remember your special right triangles. So sine pi over 4 is 45. Sine is opposite over hypotenuse, which is 1 over square root of 2. Cosine is adjacent over hypotenuse, which is also 1 over square root of 2. Therefore, the answer is 0. Unfortunately, the one on the quiz I don't think is quite that easy.
Great.
So let me do a different example. If it said cosine of pi over 3 minus sine, no, let me leave it cosine. Cosine of pi over 6,
Those are the first two numbers.
okay? 180 divided by 3 is 60. So this is a 60, 30, 90, or 30, 60, 90. Cross from the 60 is square root of 3. Next to the 60 is 1, and this is 2. So cosine is adjacent over hypotenuse, or 1/2. 180 divided by 6 is 30. This is the cosine from the 30, so you really don't have to draw another thing, another triangle. You just go to here and go adjacent over hypotenuse. And it said minus or plus, it doesn't matter, but can we simplify that? Exactly, it says exact answer. Does exact mean you type it in your calculator? No, because the square root of 3 is an irrational number. The only way to write it exactly is as square root of 3. You could leave that answer and I'd be okay with that. You really should, I suppose, yeah, combine it like that. But I'm just warning you that it could be more like that than something easy like 0, okay, tomorrow on the quiz. Yes.
Say that the second minus the cosine of pi over 6, say that was in the second quadrant. So would it be subtracting a negative number? Or a negative whatever, since it's all students of the second
Yes, yes.
quadrant? Okay.
I think they're all first quadrant angles on that question on the quiz, but you know, I'm not sure they're all adding and subtracting, though. It could be multiplying, okay? If this had been multiplying, guys, then you would have had 1/2 times the square root of 3 over 2, so you would have gotten square root of 3 over 4, okay? I don't remember what it is, but I'm just doing some examples. Okay.
So just assume they're all in the first quadrant.
You don't have to assume anything. They are all in the first quadrant. They're either pi over 3s, pi over 6s, pi over 2s, maybe. I don't think so, but okay. I just that particular question. What about 27, 28, 29, 30? Anything?
I thought we were supposed to, yeah.
28 and 29 were crossed off. Yes, you're right. Let's go over 30 and then I'll be done with this review stuff, okay? It says sine of theta times secant of theta. And that part's easy. The weirdness is it says you must answer in terms of cotangent of theta. That means your answer needs to be cotangent, or cotangent squared, or 1 over cotangent, or 1 over cotangent squared, or cotangent cubed, or some weirdness like that, okay? And when you do this problem, this is just sine over 1, and secant is what?
1 over cosine.
1 over cosine. So most of us would have said, well, that's sine over cosine, which is what, guys? Tangent. Okay. How do you write that in terms of cotangent?
1 over cotangent.
Okay, 1 over cotangent. I just want to make sure we talked about that. I don't want anybody to freak out. I don't think it's that, honestly, that tricky on the quiz. I think it's a little bit easier, if anything, but. Okay, I don't have anything else for the review. Can I go over some questions on the multitude of worksheets that are due? Yes,
On the linear and angular velocity chart.
yes.
Number 11.
Okay, this is the linear and angular velocity worksheet. Question 11. You know, at first I thought area of a sector, I gave everybody that formula, why are they asking me this question? And then I realized, because it doesn't give you the stuff you need for this formula. Area of a sector that's on 11b is 1/2 r squared theta. But this doesn't give us theta. It says a central, oh yes it does. Okay, the central angle is 4 radians, so we know this. But it gives us arc length instead of an r. Arc length is s. What do you know about s? What is that formula? Okay, so if we know s and we know theta, to find r we would need to divide. Does that seem okay? So 8 divided by 4, I think we can do that. I think the radius is 2 inches. I don't know what that squiggle is, sorry. 2 inches is the radius. So now we would have 1/2 times 2 inches squared times the, this is the linear and angular velocity worksheet. It was not part of the packet. It's the one we did last couple days, little bits and pieces of. I'm getting 8 square inches, yes? Something else on that worksheet? Yes. Number 10. Weird question, but the minute hand of a clock is 2 centimeters long. How far does the tip travel in 30 minutes? Can anybody help me out?
Is that 10?
30 minutes would be how many degrees? 30 minutes of the clock? Halfway around, right? Okay, pi radians, or 180 degrees. Yep, pi radians. Is our angle, okay? Because this is half of a rotation. And what is this telling us? If the minute hand of the clock is that long, that's the radius. And how far does the tip of the hand, tip of the clock travel? It just wants this, which is an arc length. So we just need to do s equals r times theta. 2 centimeters times pi is going to be 6.28 or 2 pi centimeters.
What? I got 3.1. Oh no.
Did you? I don't know if you cut the radius in half accidentally, or if you thought 30 minutes was only half a pi. I don't know. what can I answer? Any other questions on this worksheet?
Right now, does it matter if I'm in radian or degree?
Only if you're hitting sine, cosine, or tangent does it matter if you're in radians or degrees. If the angle you're putting in is in degrees, or you want an angle in degrees, yes. Okay, are we done with this one? 'Cause I'm gonna close this.
Can you go to 24? Or did we do that one already? I think we did it. I don't know. I have something written down. I have to look for it.
I think that's part A, B? I mean, it's only part of the question. No, it's the whole question. That's the answer. I lied. Do you have something written down?
Yeah, I have that.
Okay. I was thinking it was 24, and 24 has kind of two answers, but.
Oh, because you want to clarify too? Okay.
Well, because it asks for it once with a 2-inch center, and then it says, then find it with a 1-inch. So the first time you multiply by 2 inches, and the second time you only put in a 1 right here. Okay?
Wait, so
3,600 times 2 pi makes the angular velocity 7,200 pi radians per minute. And then it says if there's distance of 2 out from the center, the radius would be 2. And then it says redo it with a distance of 1. And it's just angular velocity times radius will give you the linear velocity.
So then you just do 2 times 7,200 pi is your first answer, and your second answer is 1 times 7,200 pi?
Yes.
Okay.
Inches per minute. Nothing else on that one? Okay, I'm closing it, never to be seen again. Actually, I'm gonna save it. Because it already says with examples, okay.
it's not bad.
Yes,
I used that.
yes.
I mean, not in.
Did you see the tape is still going, Ms. Softflower?
The what?
The recording's still going?
Yeah, because I was just waiting to see if anybody had any questions. I wanna, on any of these other ones, did anybody have a question they wanted me to go over? I didn't want Sierra to miss anything here. Anybody 5-1, which is 10B and 11? Or 8B and 9A? Or this was worksheet 7? Did we do an example on worksheet 7A of these kind?
No, sick.
This is actually the other thing that I did today with every class, I think, was go over an example on 7A of these 43 through 48.
We did Germany.
Okay, thank you. That looks so nice and straight from here, and then it's not straight from where you're at. Okay. This is all about finding the right quadrants so that you get the signs right. Do you remember all students take calculus? Remember we talked about that? This means all of them are positive, the sine is the only positive, the tangent is the only positive function, and the cosine is the only positive function. So, in this quadrant, cosine is negative and tangent is negative. Down here, sine and cosine are negative. And over here, tangent and sine are negative. So question 44 I'm going to do as an example. It says the sine is 1/4. So I'm in which quadrants could the sine be positive 1/4?
First and second.
Okay? but it says the tangent is less than 0.
Second.
Okay, so if the sine is positive and the tangent is negative, I have to be in quadrant 2. And I feel like I haven't stressed this enough, but when you are talking about coordinate plane trigonometry with triangles here, you need to be using the little bow tie triangles. Everybody know what I'm talking about?
Nope.
The 4 off of the x-axis. You can never draw your triangle like this, okay? It's always got to be with the x-axis. We just call them the bow tie because it kind of looks like a little bow tie here, okay?
Oh, that's what that, okay.
So if I'm in quadrant 2, it's this way. I can't draw it going up and over to here.
All last year, I thought that bow tie thing was something special to help him. And I always drew my triangles that way. I was just like, what's the bow tie?
The bow tie triangles, see? Or the little trig man. I don't know what you want to call him there. Okay. Sine is opposite over hypotenuse, so we have opposite and hypotenuse. How can we find this adjacent side?
Pythagorean theorem? I don't know.
Okay, Pythagorean theorem is exactly right.
Yeah.
4 squared minus 1 squared is 15, so the square root of 15. And because we're in that quadrant, what do we need to remember?
It's negative.
Yep, going to the left is negative. So this question asked for the cosine and the cotangent. The angle is always the one with the x-axis here, so the cosine was adjacent over hypotenuse. And the cotangent, instead of opposite over adjacent, would be adjacent over opposite, so it would be negative square root of 15 over 1. All right. Would you like me to set up one of the 3 you have to do, or not?
No, it's all good.
Mariana?
Instead of 44.
I will set up 44.
Isn't that 44 right there?
We just did.
No. Oh, you don't have to do 44. Okay, 45, yes, absolutely. I was with you. I was like, yeah, I can do that. All right, 45. The tangent, find the tangent and secant. If the sine is negative, right? The sine is negative, and the cosine is positive. Okay. So I'm going to get rid of this little triangle. Where is the cosine positive, but the sine is negative? Are you okay with that part? You understand how we got that? Okay. The sine is negative down in this quadrant. Sine is opposite over hypotenuse. And remember, the hypotenuse is always positive, so that sine of negative 2/5 means we went down 2 here. If we do Pythagorean theorem, 25 minus 4 square root of 21. Did I do that right, guys? And it wants the tangent and the secant. Are you okay with that part? Okay, I was just going to set it up for you. All right. What else? Is there something else on another page I can help with? Marco, anything?
55.
Is it on this same section? Okay, you're just using this formula right here. This is just a plug it in question. If angle 1 is 83 degrees, and this is a Greek letter mu, I actually knew that one, times the sine of 36 degrees, and it wants you to find that mu, the angle, index of refraction it's called, how much the glass bends the light wave. So you're just gonna, oh, that was supposed to be a 36, wasn't it? Sorry. You're just gonna divide, okay? And then for 56, you're finding the sine. not the angle itself, just the sine. So you have the sine of 42 equals 1.52. It tells you times the sine of this. So you just divide again. Normally we wanted to know the angle here, but apparently we're not doing second sine. It just asks for the sine. Emily, any questions on anything? Luke? Zachary? Can I do it? Nope.
You're sounding a bit desperate.
No, I was just about to say that.
Good, good.
Just trying to check with everybody. Okay.
I mean, that's not a bad thing.
No, it's
You're a
great.
good teacher. Good teachers.
I'm
need-
desperate to help somebody. Shayla, any ones you're stuck on? All right. Sorry, Sierra, they won't let me do any more for you.
Bye!
Feel better. Hope we see you soon.